Venus, Earth's twin brother. Venus, often called Earth's twin brother, shares many similarities with our planet in terms of size, composition, and internal structure. However, conditions on Venus are so extreme that comparing it to Earth seems almost ironic. Venus is approximately the same size and mass as Earth, with a diameter of about 12,100 kilometers compared to Earth's 12,742 kilometers, and a gravity of 8.87 meters per square second, very similar to Earth's. However, what has happened to Venus over billions of years has made it an almost uninhabitable place. The atmosphere of Venus is 96.5% carbon dioxide and 3.5% nitrogen, with traces of other gases, such as sulfur dioxide, creating a dense and impenetrable layer. The clouds of sulfuric acid reflect sunlight, creating an uncontrollable greenhouse effect that raises the planet's surface temperature to an astonishing 462 degrees Celsius. Hotter than Mercury, the closest planet to the Sun. That's hot enough to melt lead. Additionally, the atmospheric pressure on Venus' surface is 92 times greater than Earth's, equivalent to being 1 kilometer underwater in the ocean. If that wasn't enough, Venus also rotates slowly, and a day on Venus lasts longer than a year. This happens because the planet has a retrograde rotation, meaning it spins in the opposite direction of most planets in the solar system, including Earth. A Venusian day lasts about 243 Earth days, while a Venusian year lasts 225 Earth days. These conditions make exploring Venus a great challenge. But that was precisely what motivated the Soviets to launch the Venera project, a massive effort to explore the planet. And as we will see, the exploration of Venus was full of difficulties, breakthroughs, and innovations. The initial challenge, the first attempts. At the height of the space race, the Soviet Union was in a constant battle with the United States for supremacy in space. The Soviets had made great strides, such as launching the first artificial satellite, Sputnik, and sending the first human into space, Yuri Gagarin. But the greatest achievement up to that point by the United States, the moon landing in 1969, put the Soviets under pressure. The space race was intensifying. In 1967, the Soviets launched Venera 4, the first probe to attempt to explore Venus. The goal of Venera 4 was simple: study Venus' atmosphere by measuring its temperature, pressure, and composition. The probe was equipped with a capsule that was supposed to descend to Venus' surface, but as soon as it entered the atmosphere, it was crushed by the immense pressure of the planet. It managed to transmit data until it was destroyed, but this data revealed that Venus conditions were even more extreme than scientists had imagined. Despite Venera 4's failure, the Soviets did not give up and continued sending missions. The Venera 5 and Venera 6 probes, launched in 1969 and 1970, also failed shortly after arriving, crushed by Venus' overwhelming pressure. However, these failures provided crucial information to Soviet engineers about what needed to be adjusted for a probe to survive and send vital data from the planet. The turning point: the success of Venera 7. After several unsuccessful attempts, Soviet engineers began designing more robust probes. In 1970, Venera 7 was launched. The key improvement of Venera 7 was its reinforced design. Inspired by submarine construction, known for withstanding immense pressures in the ocean depths, Soviet scientists developed a stronger probe capable of surviving Venus' extreme conditions. Venera 7 made history as the first probe to successfully land and transmit data from Venus. However, the mission was not without challenges. When the probe reached Venus' surface, its parachute melted due to the intense heat, causing it to crash land. Despite this, It survived for 23 minutes and managed to send data about Venus' surface temperature and pressure. This data confirmed that Venus was incredibly hot and had a crushing atmospheric pressure. Venera 7 was the first true success of the Venera project and paved the way for future missions. The breakthrough, Venera 9 and Venera 10. After Venera 7, the Soviets realized that for a probe to survive Venus, it needed significant reinforcements. The Venera 9 and Venera 10 probes, launched in 1975, represented a major technological leap. In addition to being more resistant, they were equipped with advanced technology to capture images of Venus' surface. In 1975, Venera 9 made history again by taking the first-ever images of Venus' surface. The images revealed a barren, rocky terrain that looked more like the bottom of the ocean than any other planet. The orange sky, caused by the thick atmosphere, gave the photos a surreal tone. The images also provided evidence of active geology on Venus, suggesting that the planet might have had a more dynamic history than previously thought. Venera 10 followed a similar path and captured more images of the planet. Together, the Venera 9 and 10 probes helped provide a crucial overview of Venus' surface, revealing what appeared to be a desolate world with signs of geological activity. The innovation, Venera 13 and 14. The success of the Venera 9 and 10 missions motivated further studies of Venus. In 1982, Venera 13 and Venera 14 were launched, bringing some of the most fascinating discoveries of the entire Venera project. In addition to continuing to capture images of Venus' surface, these probes achieved a remarkable feat. They recorded the sounds of the planet. Although the audio data was not publicly shared, it is known that the probes used microphones to capture Venus ambient sounds, helping scientists study the planet's atmospheric dynamics. These sounds likely consisted of violent winds and storms occurring on Venus. Although the audio remained a mystery for a long time, it sparked great interest, especially since, at the time, scientists did not expect Venus to have such an active environment, considering its extreme conditions. The legacy of the Venera project. Despite the initial difficulties and failures, the Venera project was a significant milestone in space exploration. The missions provided crucial information about Venus' atmosphere and conditions, which continue to be used today to plan future missions to the planet. The project also represented a major advancement in space probe engineering, proving that humanity can develop technology capable of surviving even the most hostile environments. Venus, with all its hostility, remains one of the most mysterious planets in the solar system. But the courage, persistence, and ingenuity of Soviet engineers opened the door to understanding an alien world. The Venera project not only helped the Soviet Union leave its mark on the space race, but also greatly contributed to the advancement of human knowledge about space and the planets beyond Earth.